We have division of algebraic fractions. We will use the same rule for division algebraic fractions like for division of fractions. So it means we have to copy first algebraic fraction. So we have that this is equal, we have in parentheses y plus 3 over y plus 4 to second power. Next, we have to change division sign to multiplication. We're going from left to right. And now we have to flip this fraction. So we will have y squared minus 16 in the denominator, and in the numerator and in the denominator we will have y squared minus y minus 12. And again we have division, so we have to change to multiplication. And we have to flip this algebraic fraction. So in numerator we will have 64 plus y cubed over 27 plus y cubed. So this is equal. First, we have to do the power. We have to take to the second power this whole algebraic fraction. So we have to take numerator to second power and denominator to second power. So it will be y plus 3 to second power over y plus 4 to second power. And now when we multiply algebraic fractions, we have to multiply numerators times numerators and denominators times denominators. So I will put now only one fraction bar, and in the numerator we will have times y squared minus 16 times 64 plus y cubed over y squared minus y minus 12 times 27 plus y cubed. This is equal. What next? We can rewrite that y to second power minus 16 is y squared minus 4 to the second power. This is equal y squared minus 4 to second power, and 64 we can write that this is 4 to third power plus y cube. 27 it will be 3 to third power plus y cube. So let me copy this one more time. So we have y plus 3 to second power times y squared minus 4 squared times 4 cube plus y cube over we have y2 plus 4 to second power times y squared minus y minus 12 times 3 to third power plus y cube. So this is equal. Next, I will copy y plus 3 to second power. Next, we have difference of two perfect squares. So let me remind you formula when we have a minus b, of course a squared minus b squared, this is equal a minus b times a plus b. So we have y squared minus 4 squared, so it will be y minus 4 times y plus 4, and we have sum of two perfect cubes. So let me remind you formula. When we have a cube plus b cube, that this is equal a plus b times a squared minus ab plus b squared. So now we can rewrite the third parenthesis and we will use this formula. So we will have 4 plus y times 4 to second power, so it will be 16 plus 4, of course minus we have minus 4y, and we have plus y squared. close parenthesis, and in denominator we have y plus 4 to second power. Next we have trinomial y squared, so coefficient before y is 1, so we can check if we can factorize this. We have to find two numbers. At the beginning we need to have y because we have y squared, so y times y give me y squared. And now I have to find two numbers which I multiply, and I will have negative 12, and when I add them I will have negative 1. Here's invisible 1. So it will be negative 4 and positive 3. Negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. So I will rewrite this trinomial to these two products, and the last we will use the same formula. Now a is equal 3 and b is equal y. So we have 3 plus y times 3 to second power, so this is 9 plus 3, of course minus again, I forgot, 3y, and we have plus y squared, close parenthesis. So this is equal. Next we have multiplication, so we can check if we can reduce something. We have y minus 4 and y minus 4, and we have y plus 4 and 4 plus y is y plus 4, is the same. So let me rewrite this. We have y plus 3 to second power, and we have y plus 4 times will be y plus 4. So y plus 4 times y plus 4 will be y plus 4 to second power, and in the last parenthesis we have 16 minus 4y plus y squared over, and we have y plus 4 to second power, and we have y plus 3, and the next parenthesis we have 3 plus y, so this is y plus 3. So I have y plus 3 times y plus 3, so I can put y plus 3 to second power, and we have 9 minus 3y plus y squared. So this is equal. We can reduce y plus 3 to second power with y plus 3 to second power, and y plus 4 square we can cancel out. So now we can write what we have here: 16 minus 4y plus y squared over 9 minus 3y plus y squared. We can rewrite and we can start from y squared, so it will be y squared minus 4y plus 16 over y squared minus 3y plus 9. You can check if we can factorize this. We can use the delta formula. Delta is equal b squared minus 4ac. What is b, a, and c? When we have general quadratic trinomial formula, this is a x squared plus b x plus c. The coefficient before x squared is a. The coefficient before x is b, and the constant is c. So if delta will be greater than or equals 0, it means we can factorize this two trinomials. If delta will be less than 0, it means that we cannot find the real solutions. So let's check the delta. For the first example, let me copy this. We have y squared minus 4y plus 16. So delta a is coefficient before y squared, so this is y. B is coefficient before y, so it's negative 4, and constant c is 16. So delta is equal b squared minus 4ac. This is the formula, so this is equal b to second power, so negative 4 to second power minus 4. A is 1, c is 16. So this is equal negative 4 to second power, so this is 16, minus 4 times 16 is 64, is equal negative 48, is less than 0. We cannot factorize our numerator. The same we can do with the numerator, we can check. Let me copy this formula. We have y squared minus 3y plus 9. So a is equal 1, b is coefficient before y, so it's negative 3, and c is constant 9. So delta is equal b squared minus 4ac. So this is equal, this is the formula. So we have b squared, so negative 3 to second power minus 4 times 1 times 9. So this is equal negative 3 to second power, so this is 9, minus 4 times 9 is 36, so this is equal negative 27, is less than 0. So it means that denominator we cannot factorize 2. So this is my solution.